Now in the future, especially driven by the emergence of artificial intelligence powered applications, voice will become more and more important for the interference between humans and machines. Now you can see this in cars when you talk to your car. You can see this when using ChatGPT through your voice. And this will continue to become more important in the future. And to capture this voice, we need XENSIV microphones. And today we want to help you capture that in the future. Now, that means, first of all, we will give you an overview of what a MEMS microphone is and what the technology behind MEMS microphones is. Afterwards, I will guide you through our Infineon XENSIV MEMS microphone portfolio and what you can expect going forward into the future. We will talk a bit about general MEMS microphone applications and what they require, what kind of specs or what kind of features they require in a MEMS microphone. And then I will explain to you why you should really value high signal to noise ratio, high SNR MEMS microphones. And because we only have a limited time for today, I will also give you some information on where you can find further information, data sheets, trainings, and more. My name is Daniel Wieswesser. I'm product manager for MEMS microphones. And now I would like to hand over to Mats.
So hey guys, my name is Mats. I'm an application engineer here at Infineon, and I'm responsible most of the time for our MEMS microphones. So today, I really want to give you an insight into what makes our microphones special. And to start off on this, I do have a small sample here for you to actually have a look at what a MEMS microphone looks like. So I'll hold this to the camera so that you can see the small size of it. So this is one example of our high SNR MEMS microphone. This one is a digital one, which you could find in most of your daily devices which have microphones. So speaking of your laptops, your smartphones, your watches maybe, all of these devices rely on Infineon technologies to sense your voice. The key to a good microphones is the SNR performance. And to really showcase this, today I want to hold this training for you using one of our high SNR microphones. So to do this, I'm going to switch my microphone now and show you the true performance of Infineon MEMS microphones. Recording now is our newest analog high SNR microphone, and you should clearly be able to hear the difference between a standard laptop microphone and our top of the line microphones. Impressive what kind of performance we can get out of this size. So what is a MEMS microphone? A MEMS microphone is a microelectromechanical system transducer which turns the sound waves propagated through the air into electrical signals. The key here is that we use semiconductor-based technologies to produce high-quality microphones on a large scale. The microphone, which you saw before, consists of three parts which are vitally important to the performance and the overall workings of the microphone. First, we have the advanced acoustic sensor. This sensor is being actuated by the sound waves. The membrane swings with oscillators, and this generates an electrical signal which can then be amplified by our Infineon-owned ASIC technology. This combination allows us to turn signals, voice signals, sound signals over the air into electrical signals, which can then be used by your everyday devices as you know them. The last important step is the enclosure, the package of the microphone, because this provides proper acoustical working environment for the microphone, but it also provides the mechanical protection against any environmental influences that one can see. It also shields against any RFI and EMI measurements. At Infineon, we own all three parts of this value, of this keychain. Generally, in the consumer market, we see two different types of microphone technologies. We first have the microelectrical mechanical system microphones, which we specify in. But one of the more fierce competitors for these microphones are the electrode condenser microphones, also short ECM microphones. These have been widespread in the industry for their advantages in performance and design flexibilities. But with our MEMS microphones, we now can reach similar performance values with much smaller sizes and higher robustness against ECM microphones. Most of the MEMS microphones come in two different designs. These designs vary deeply in the application where a MEMS microphone is being implemented. The most important feature of a MEMS microphone in the package is the location of the acoustic porthole. So this is where the sound waves enter our package and can attenuate the membrane of the microphone. Bottom port microphones tend to have a larger back volume and therefore higher SNR performance capabilities, but due to some niche use cases, a top port microphone where the acoustic porthole is on top of the microphone might be beneficial for ease of integration into your systems. With this, a reduced back volume though, with like the top port microphone, you can see we have a reduced back volume of the MEMS. We at Infineon specify on bottom port microphones for the reason of the higher performance. In general, MEMS microphones are available in both digital or analog interfaces. The decision on which interface to take lands on with the integrator and is usually taken into consideration which interface is needed by the audio codec receiving the signal. Infineon has ASICs, so signal amplifiers for both of these. In general, the analog one is simplified amplifier inside to amplify the electric signals, while the digital has a really complicated amplifier, also digital gain already applied to the signal. MEMS microphones offer highest possibility of performance while also having high robustness features. This is mostly described in the IP rating of the microphone. As some of you might know, IP ratings from your phones, as really prominent examples are advertising their phones with IP ratings. The IP stands for ingress protection here and means how well the device is naturally protected against solid objects or liquids. In general, all Infineon microphones are IP57 protected, or have the IP57 certificate, and can be by the addition of just a membrane IP68. So what are the benefits of our MEMS microphones? Because they do have a lot. So the most pronounced advantages of taking the MEMS technology compared to the ECM technology are the low cost. So we have a cheaper implementation, small size, robustness, as spoken before, really good performances, but not only the high performance, but also really tight performances next to each other, the microphones. So especially for beamforming applications, which Daniel will introduce later, this is really beneficial to have good part-to-part performance. In the end, also MEMS microphone with this high robustness and this package make it really easy to be handled by any pick-and-place machine and also be able to be reflow soldered. So an Infineon MEMS microphone is not just any Infineon MEMS microphone. We offer two different types of microphones, which come down to the MEMS technology used. The sealed dual membrane technology is our high-end technology, coming down to its Infineon proprietary technology, using two membranes in the semiconductor to get true differential signal from the MEMS. So we really have two different signals coming into our ASIC, leading to a high performance microphone. Compared to the sealed dual membrane, we also offer a single backplate technology. Single backplate here stands for a single-ended output signal of the MEMS. So we have one membrane. Our single backplate technology is best used for smaller sized microphones with high robustness needs. So for these two technologies, we really try to achieve highest possible signal to noise ratio in terms of the size of the MEMS, size of the chip. So the name of the game here is really to increase the performance per die area of the MEMS. And as you can see, our single dual membrane is playing in the higher SNR ballpark, while our single backplate is in the lower regions, but also with the lower size. So both of them have different application use cases and different benefits. So what makes our sealed dual membrane technology special in enabling also up to 80 dB or even higher SNR microphones? So really studio quality microphones here. What makes the technology special is using two membranes stacked around a stator, electrical stator, which first of all seals the sensor, so it has higher robustness. But also by using two electrical separated membranes, we get a true differential signal, allowing for ultra high SNR of up to 76 dB, or even above 80 dB for using two membranes in one microphone, two MEMS in one microphone. The distortion of the microphone is also improved by this differential signal. Not to forget about our single backplate technology, as it also scratches at the high performance of the microphones with up to 69 dB SNR. Our sealed dual backplate technology is special due to Infineon innovation, which make it ultra high, ultra robust compared to our competitors. Just to highlight two features which have been developed in-house here at Infineon. These are the so-called flaps in our membrane and also the landing pads. The flaps are more or less doors which opens under really, really high pressure. So pressure of outside of any acoustical regime, but pressures which can happen during cleaning of your phone or during drop scenarios where the phone is being dropped. And after such a case, such a scenario, you still want your phone to work. You still want the next phone call to sound as good as the previous one. So for this technology has air gaps which can open and have in the case of an extreme pressure event, the membrane is equalized so it does not break. The landing pads have the key feature of being able to protect the very delicate membrane of hitting the backplate, which can happen in really high SPL cases, or really high sound pressure levels. It can happen that the membrane hits our backplate, and having small bumpers to protect it goes a long way here. So now I hope I could give you some insights into our microphone technology here at Infineon. And I will hand over now to Daniel to give you a little bit more insights into the portfolio and what comes next for Infineon in the microphone game.
Thank you very much, Mats. That was a very impressive demonstration, especially of using our high SNR microphone. And I want to say the most impressive part is usually when you use a laptop microphone or a mobile phone microphone, you have 3 or 4 microphones in one system, and afterwards some signal processing that obviously improve the quality of the sound. Now, what you just did is do the whole recording with just one single microphone and without a lot of signal processing, meaning that this performance was really, really outstanding. Now, after you have learned something about what a MEMS microphone is and how it works at Infineon, I would like to show you what kind of MEMS microphones at Infineon we actually have. Now, when it comes to selecting the right MEMS microphones, it's crucial to look at a certain set of parameters, characteristics, features that play a significant role in many applications and vary from application to application, meaning that for some, one is more important and for others, another feature is more important. Obviously, MEMS microphones, as Mats has already explained, vary a lot in their audio performance. But they also vary in their overall package size, meaning some applications need very small packages. They vary in their power consumption, meaning that some microphones consume less power than others. And some, if you look at the bottom here, even have different power modes, like a normal mode and a low power mode, where the performance of the microphone decreases, but also the power consumption. And also, as Mats has explained, robustness of the MEMS microphones plays a very crucial role, especially if you think of mobile phones or for example, wearables that you wear in rough weather conditions as well. So for these applications, you need to care about robustness. When we look at our Infineon MEMS microphones, we usually highlight a certain set of parameters that specify the audio performance of these microphones, and these are listed here. The first one is, as Mats has already explained, the signal-to-noise ratio, which means compared to an input signal of 94 dB sound pressure level, so 94 decibel sound pressure level, how high is the noise floor, so the self-noise induced by the MEMS, by the microphone itself. If you see this here, the 72 dB signal-to-noise ratio MEMS microphones means that the noise floor at a sound pressure input level of 94 decibel sound pressure level, the noise floor is only 22 decibel. The second key characteristic is the acoustic overload point, meaning the highest sound pressure level before the microphone output gets heavily distorted, meaning the acoustic overload point is defined as the sound pressure level where the audio signal is distorted by 10%. We also specify the sensitivity, which gives the output value in relation to the input value, so the sound level. We also specify the current or power consumption when classifying these microphones, and the corner frequency, which just indicates at which low-end frequency the sensitivity changes majorly. Now, when we look at our portfolio, we name our Infineon microphones according to these parameters, meaning that all Infineon XENSIV MEMS microphones are named IM for Infineon microphone. Then comes a 2-digit number specifying the SNR. Then either a D for digital or an A for an analog microphone. The next 3 digits then give you the acoustic overload point. Then comes one letter that indicates the nickname of the microphone. This one is, for example, called Vega, and then the version number. So when we click through our portfolio on the next slide, you will see these names of the microphones. Now, I won't go through every single microphone in our portfolio. I just want to give you a feeling of the microphones that we currently offer. So in the analog microphone space, we offer 3 different microphones using different technologies, single backplate and sealed dual membrane, that show different sizes, that show different signal to noise ratio values, different acoustic overload points, different corner frequencies. So if you will need an analog microphone, you really have a full selection here of rather small sized and cheaper microphones, or the very high performance, very high size, very large size microphones. On the digital side, Infineon offers way more microphones. Now here you can also see from the left side to the right side, we offer microphones in a signal to noise area between 66 on the left side and up to 73 decibel SNR on the right side, using different technologies the ones we just said, single backplate and sealed membrane, plus some old technology, dual backplate microphones. We offer different sensitivities, we offer different AOPs, we offer different power consumptions, and we offer different corner frequencies. So basically, as explained on an earlier slide here, it really comes down to what you favor and what you need in your application to select the right microphone for you. To find out which microphone really best fits your application, you don't need to just rely on the characteristics. You can also test them yourselves. And for that, we offer some support. Namely, on our website, you can order, first of all, the Flex kits, meaning this is just a kit where you get one adapter plus 5 MEMS microphones soldered on these little flexes, as Mats has showed them earlier in the camera. And these you can easily connect to your system. Now, you can also go one step further and order the Audio Hub Nano, either in a digital or in an analog version. Now here you can plug in 2 of these flexes, 2 different microphones, 2 of the same version. And you can also do some first audio processing, meaning that these ones are really plug and play. You can just record your audio and reuse it, use it directly in a system like your laptop. Mats has shown this earlier. For automotive applications, the A2B eval kit is really helpful because the A2B format is used in automotive a lot. And this one you can also order on our website. We will provide you with the slides afterwards, and here you can really just click on the links and order any one of those. Now that you've seen what kind of range, what kind of spectrum we at Infineon offer in our MEMS microphones, let's talk a bit about what are the key applications for MEMS microphones and what are the key parameters and characteristics you usually look at when deciding for a microphone in one of those applications. Here we've listed a few of the key applications where MEMS microphones are used. Obviously, there are many more, and really there's no limit to your ideas of how you can use them. But the typical ones are listed here. In smartphones, the key parameter is often the excellent audio performance, even more in the future. As I indicated in the beginning, smartphones will rely more and more heavily in the future on AI applications and AI powered functions in there. So for AI applications, for AI algorithms especially, high SNR plays a very crucial role, and I will get to that in a minute. The second application is TWS, True Wireless Stereo, meaning earbuds and headsets. Now here, the audio performance plays an even stronger role because these are really applications where audio is the key feature. But also you need to look at low power consumption, especially in earbuds, because you just don't have space for a huge battery. In laptops or tablets, on the other hand, a very crystal clear communication, even in high sound pressure levels, is key most of the time, meaning that we look at the AOP, the acoustic overload point, here more often. For smart home applications, especially smart speakers, you need an extended voice pickup distance, meaning, once again, the high SNR is very relevant here. In automotive applications, you need high SNR, high performance, but also extraordinary robustness, especially when you talk about external automotive applications like external communication with the car, siren detection, or others, where microphones are mounted on the outside of a car. In these cases, they obviously need to be very robust. Now, there's a lot of other applications like robotics, industrial applications, medical applications, and more. And MEMS microphones can play a huge benefit in many of them. And you just need to find out what kind of characteristics are key for these applications. Is it the robustness? Is it the package size? Is it the power consumption? Or is it different power modes, for example? You just need to find out what is key for your application, and then you can select the right MEMS microphones from Infineon for your application. Now, I've mentioned a few times now that high SNR values are very important, or high SNR microphones are very important for a lot of applications. Now, why is this the case? Well, first of all, it's key to understand that the sound pressure level halves once the distance from the sound source to the microphone doubles. Meaning that if you look at the bottom of this slide, if a person speaks from 1 meter distance into a microphone, and this signal has a sound pressure level of 60 decibel, when the person moves away to 2 meters distance, we lose 6 decibel of sound pressure level. This is according to the calculation formula of decibel. And the further we go away, the lower the input sound pressure level is. Now, if you have a very high self-noise of the microphone, let's take, for example, 30 decibel, then, and you're 8 meters away, then you only have a very little difference between the actual input and the noise, meaning that the output quality will be rather bad. So this is why high SNR is needed for many applications. Now, recently we've seen voice as a key user interface between humans and technology advance more and more strongly, so that AI assistants become not only go from helpful assistants more to personal companions. Now here we've made some internal studies on different steps of these AI use cases, from just simple awake word detection to speech recognition, meaning to really recognize the words that have been spoken, to actual speaker diarization, meaning that the algorithm is supposed to recognize when the speaker actually changes and when the speaker, the first or the second speaker, speaks again. Now, the first study we made is looking at the simple word recognition, and we've tested several microphones from 66 to 73 dB SNR in a quiet environment, and the speaker went further and further away from the microphone. And as you can see here on the right side, when the speaker is very close to the microphone, there's really no big difference between the individual microphones. But the further the speaker goes away, the higher the word error rate gets in a low SNR microphone compared to a high SNR microphone. Meaning, in a typical application like smart speaker, where you probably all the time stand further away than 2 meters, it's really valuable to have a high SNR microphone because it's just easier for AI algorithms to really detect the words that have been spoken. Now, in the second study, we looked at the speaker diarization, meaning that we used 2 different microphones in our Audio Hub Nano. We used in a large language model from NVIDIA, which offers speaker diarization, meaning that the system is supposed to recognize when speaker A and when speaker B is speaking. And we tried this in different environments, once in a very quiet environment and once in a very loud environment. And the results, as you can see here on the left side, we have the quiet environment. Once again, there's no huge difference between the high SNR microphone on the bottom and the low SNR microphone here in the middle, meaning that we have a diarization error of around 10% in both cases. But if you look on the right side, the low SNR microphone is only able to detect one speaker in combination with this AI algorithm, and has a very high diarization error of 70%, whereas the high SNR microphone is really still able to detect 2 different speakers and classify them most of the time correctly, leading to a reduced error rate of only 22%. So we really see a huge difference between high SNR microphones and low SNR microphones when it comes to AI voice dependent algorithms. Now, Mats and myself have explained to you what a MEMS microphone is and how it works, what kind of MEMS microphones we as Infineon offer, and which ones you should select for your applications, and why high SNR plays a crucial role in many applications. But obviously, there's still a lot left to be discovered and a lot left to be learned. So we also want to give you some advice on where you can find more information. First of all, we have an Infineon website separately for our MEMS microphones. Here you can find all of our products and more information at any time. You just need to scan the QR code or go on the link on the bottom and click yourself through a page. You can also register on our website for My Infineon and then click through even more information on MEMS microphones. Here you can find product presentations, application notes, white papers, articles, and more that can help you understand MEMS microphones even better. We also offer MEMS microphone training videos if you're interested in that. We have two of those, one very general high-level introduction training, and also one that really helps you select the right MEMS microphones for your key applications. And if you have very detailed technical questions, you can also just register for our MEMS developer community. Here you can discuss with experts at any time. You can write forum entries, and you can get feedback from our application engineers, which are really experts on very detailed technical questions. So, thank you very much for joining us, and I hope we could help you to understand MEMS microphones better, and I hope this enables you to capture the voice of tomorrow with our MEMS microphones even better.
All right, well, thanks Daniel and Mats for that really detailed presentation. It's so interesting to hear about all the new applications for microphones. It's pretty astounding. So we've already got several interesting questions, but I do want to let our audience know that there's time to submit your questions using that Q&A box on the right-hand side of your screen. Gentlemen, you ready to answer some questions?
Yes.
Yes, happy to.
All right, so first one is asking is, where are your microphones produced?
Yes, excellent question. So as we highlighted earlier, the microphones are consisting of different parts. So the whole supply chain has different steps. Our MEMS, the membrane, is designed in our headquarters in Munich, Germany, and produced then in Regensburg, also in Germany, and at the second site in Malaysia, in Kulim. Our ASICs are designed in Austria, in Villach, and are then produced in Germany, in Dresden. And then the package around is done in China, in Chengdu. But obviously, we want to also work on geo diversification and everything in times like these. So we are right now building up a second backend for the packaging in Malaysia as well. This will be ready to run in roughly 12 to 18 months.
Okay, thank you. Do you have in your portfolio any IP68 qualified products?
Yes, this is also a very frequent question that we're getting here in the industry, because robustness is one of the key factors in using MEMS microphones. And short answer to this question is, we do not have them yet. We are working on a technology to really protect our MEMS, actually. So there is something in the works that we're working on. But for now, as we already highlighted in the speeches, all our microphones are IP57 tested and certified. And we did do already some tests with our microphones using only the microphone for IP68. And depending on how you define this standard, especially the drying time, our microphones already do pass some of the elements of this test. So they do not get destroyed by this test. So we are working on it, and we will keep you up to date on any developments there in the future. Yes, but in the meantime, if you are required to develop a system where IP68 is a requirement and you want to use our microphones, the common strategy here is to use one of a really well-known mesh or membrane to protect the microphone. This is done in all sorts of applications right now.
Okay, thank you. Our next question is asking, how does the signal to noise ratio impact the performance of MEMS microphones in various applications?
That's a very interesting question, very technical question as well, and one of which we handle, or we are also very interested in. And I think Daniel already gave quite some detailed information on what the benefits of high SNR are, especially in the realms of speaker diarization, so speech to text, human to AI interfaces when you speak to any AI model, for example, or want to transcribe a conversation. There we really do see some benefits of these high SNR microphones. In general, speaking of applications, the benefit of a high SNR microphone really comes to shine when you are doing something or recording something in a low, in a far field application, or a very quiet sound. So everything which has a low signal to begin with, either because it's far away or it's just by nature really quiet. So there really the benefits of a high SNR microphone come to shine.
Okay, thank you. This questioner is asking, what is the sensitivity to high humidity for the microphones?
So I'm guessing this is targeting how microphones behave under higher humidity conditions, and this is something which we have tested. We do go extensively. We value our quality extensively here at Infineon. I think it's one of our key mottos here at our company. So we do extensive tests also on humidity, and we do see an impact of humid environment in the sensitivity. So there is an impact, which is reversible though. So the key factor here is that we see that when, first of all, when you know the humid condition, the impact is known. So one can plan for it if you know your condition of the environment. And secondly is that if you then go back to a more or less humid environment, so the microphone dries again, the microphone is not harmed by any residue of this humid environment on the membrane, or it can still recover completely to its original state.
Okay. All right, Andrew's asking, what's the biggest improvement in MEMS microphones over the past few years? Is it lower noise, higher sensitivity, or better durability?
That's an excellent question, but a question that's not too easy to answer, because honestly speaking, I believe in the past few years, the trend really depends heavily on application and on which microphone we're talking about, because all of these points are topics that need to be addressed in certain applications, some more, some less. But all of these points are points where the MEMS microphone development has made huge progress over the past few years. To give you an example, let's talk about SNR, signal to noise ratio, for example. We had microphones, so maybe speaking about 4 years ago, 70 dB SNR was like the barrier, I would say, where that was almost impossible to reach. Nowadays, we're talking about 73 to 75 dB SNR, even higher for hearing aid applications. Robustness, Mats was talking earlier about the single backplate technology that we've made more and more robust over the years, now being able to resist more high pressure shocks, for example. Some other key points I would like to mention here is the power consumption, which really is a topic that has improved over the past years drastically, because in applications like earbuds or for example, smart glasses, where you don't have a lot of battery consumption, the power consumption of microphones, especially if we're talking about 4, 5, 6 microphones per device, becomes critical. And also size is a topic where MEMS microphones are developing further and further over time. So the package size, we're now, we have packages of 3 times 2 millimeter in our portfolio that still reach up to 66, 67 dB SNR. So high performance in small size packages is also one of the key topics that, well, have developed over the past years. Mats, anything to add here?
No, this was already quite a substantial list. If we're talking about where the development of MEMS microphones are heading, I think you hit some key parts. One of the bigger parts that might be able to mention here is that Infineon also is keen or is on the forefront of developing a new interface for our MEMS microphones. So with the introduction of Swiss 0.3, we are working on also developing more capabilities into the microphone as well. So the microphone will not only be more robust, more performant, but also in a way more intelligent and also more responsible to your user. So it'd be more adaptable.
Okay. Well, you picked up one of the other questions further down the chain there of what's the trends are. So awesome. We got two answers at once there. Thanks, guys. This question is asking, what are some common challenges faced when integrating MEMS microphones into industrial application?
Oh, yeah. So a very broad question. I would say one of the first aspects or one of the first challenges that would arise is how we can protect the microphone in such an application. Most of the industrial applications that we have seen are quite environmentally unfriendly, let's say it like this. So here, robustness is one of the key things that an integrator needs to account for. Maybe also then not only relying on the internal robustness of our microphones, but also developing and integrating some external protection measures like a membrane or a mesh, or also some kind of like sound channel which is not straight and doesn't allow for anything to hit the microphone directly. When designing such a thing, it's really important that any deviation of a perfect sound channels or any obstruction or any bend will have an impact on the frequency response and also performance of the microphone. So this needs to be taken into account when designing in our microphones. The good thing here is that we do have simulation tools available here at us with the teams to really help you with the integration and really tell you also upfront if you design certain parts of your design, how they will affect the acoustic performance. So if you're interested in this, just reach out to one of our experts and we will get in touch.
Okay, thank you. How does the sealed dual membrane technology affect the microphone sensitivity and noise cancellation?
A lot of technical questions here. I really like it. So the sealed dual membrane is a very interesting and very cool technology also for us. And the real benefit of is the real differential output signal of the MEMS. So we really do get two signals from the MEMS, which does in turn achieve a little bit higher sensitivity, but I would not say that this is the main part of our design or the main benefit here. The sensitivity of our microphones is mostly controlled or mostly given by the gain settings of our ASICs. So here we can individually for each microphone trim the ASIC to a target sensitivity. So that we can do for our SDM technology, but also for our single backplate technology. So a really close sensitivity matching is something which is common for Infineon MEMS microphone products. The second part of the question is understood about the noise performance of the microphones. So yes, SDM is our high performance microphones, and the two MEMS, the two membranes that we have here do give us more signal per area, and therefore we do achieve higher noise signal to noise ratio.
Okay. Technical question, and you get a technical answer. So that's what's fun about these sessions. I appreciate it. Which use cases and applications require a very high SNR compared to others?
Also a very good question. I mean, we've talked about it already a lot. Let me just quickly re-highlight this. In general, as Matt said, use cases for high SNR are the ones where you really either have a far field sound pickup requirement, or where you have rather low basically sound pressure level inputs. Also, obviously, where a low signal to noise ratio helps a lot when you try to record perfect sound, which is, for example, needed for active noise canceling in headphones or in earbuds, because you really want to mimic the incoming sound waves as perfectly as possible to cancel them. So you need to be able to measure them as perfectly as possible. And nowadays, I mean, more and more applications are now powered by or enabled by an AI application, an AI algorithm running behind it. And I believe I've shown it earlier that we are doing studies, and we can show that these AI algorithms perform way better when you feed them with precise audio input compared to higher noise audio input, meaning that we expect the trend and the requests for higher SNR to develop exactly that way further into the future, meaning that smartphones especially, or smart glasses, everything where humans interact with AI on a daily basis will require higher and higher SNR microphones in the future.
That makes sense. Yeah. What are typically use cases that require microphones in cars?
We see many use cases for our MEMS microphones in the car, especially also with the desire to be or to have more entertainment system, better call performance of your car inside, and also with the trend to more and more autonomously driving. So in the cabin, this means I do have more time to engage with other people, maybe engage over a call, but also we do see the need for, or we do see trends that people want to talk with other passengers who might be sitting behind you or might be farther away because you're driving a bus and the driver is speaking up front and cannot turn back. So there we see the need internally for good quality microphones. But also outside, we do see emerging applications like siren detection, a really big thing for autonomous driving. Or also any interaction that you might have with your car. We see a lot of development in keyless entry. There's also a world where you can talk with your car and tell it what you want to do, if you want to open certain doors or if you want to turn on the light. So there are many applications also in the automotive space which we are targeting. Yes.
Okay, excellent. Which growing applications do you see for MEMS microphones in the future?
So, I mean, the typical applications that everybody knows is smartphones, headphones, TWS. But the thing is, with AI becoming more prevailing in our lives, that really audio becomes the main human-machine interface technique, basically, for many devices that use AI. And I mean, we see some of them already, talking about smart glasses, talking about, for example, domestic robots, so a vacuum cleaner robot or something like this. In the smart home, we have examples where nowadays people are interested in having a smart fridge, for example. I recently learned that will incorporate an array of MEMS microphones. So you're able to communicate to your fridge and maybe ask, I don't know how many eggs are left, something like this. So really, there is no limit to the applications where you need MEMS microphones, because there's no limit to the applications that will become smart in the future and that require some kind of possibility of human-machine interface. And usually the best way, as we can see with glasses, with phones and everything, is the human voice.
Okay. Yeah, that's interesting. I need my fridge to talk to me and tell me to close it, right?
Also an option, yeah.
Question here is, why is environmental robustness important for MEMS microphones on the component level?
Yeah, so one of the key targets here to really be robust on component levels is, of course, to make the life easier for every integrator using our microphones, because everywhere less is a bonus point for us to choose a good quality microphone, because you do not have to worry that much about the protection of our of the microphones. We had customers really being very excited about using, for example, our SDM technology, because using this technology means that they can get rid of certain external protection measures they had in previous designs. So this not only reduces the design complexity, but it also, of course, reduces the BOM of your project. And then, of course, one of the key benefits of microphones, or MEMS microphone and specifically, is how easily or how well they can be handled in any production line. They're SMD capable, so you can solder them easily, but also with a more robust, internally more robust product, you don't need to take as much precaution in handling the microphone. So also your production line will be more simplified by a better or robuster component. So these two reasons, I would say, are the main factor of driving this here.
All right, well, thank you. It looks like we've covered all of our audience questions. Thank you again, Daniel and Mats. A great presentation and a really engaging Q&A too.
Thank you.
Yes, thank you very much.
Yeah, before we close out this All About Sensors live session, I'd like to announce our prize winners. Congratulations, Carlos Hidalgo and Jeff Staller. We'll be in touch with you within the next week to ensure we have the information we need to send you the All About Circuits goodies. In a moment, you'll be redirected to Infineon's Summit Series microsite. I encourage you to check out other live sessions, keynotes, and published content for our month-long virtual event. Thank you for attending the All About Circuits Summit Series 2025.